Okay, Bismillah, Assalamualaikum warahmatullahi wabarakatuh. So in this video, show you I would like to show you about tutorial of BGP. But for the first, I'm going to explain you about what is BGP and what is the key of concept at the BGP and many others at the BGP that I want to explain. So yeah, let's get started. Okay, so as you know, the BGP is uh, the the real name is about Border Gateway Protocol. So this BGP is a routing protocol. So it's a complex and critical routing protocol that used to exchange routing information between like AS or we can say autonomous system on the internet. So the BGP is classified like an exterior gateway protocol. So this is like the different with the IGP or interior gateway protocol. And also distinguishing it from interior gateway protocol like SPF and EGRP that operate within a single organization. So the BGP plays a vital role in ensuring data that can find its way and find way across the myriad networks that comprise the like comprise the global internet. So there is some key concept of BGP. For the first is autonomous system or we can say AS. So an autonomous system is a network that spread to be group of a network that managed by a single organization. So it has like unified routing policy. And also from the each AS or autonomous system is assigned like a unique number that to know each other at the autonomous system number or we can say ASN. So for the second is about the path vector protocol. So this like unlike traditional design vector or link state protocols, so BGP is a path vector protocol. This means that BGP makes routing decision based on the path or route data that will travel, and as well as the policy set by network administrator. So the BGP like are advertising full routing path between AS and also including all of intermediate AS number. And for the next is about interdomain routing. So the BGP is have an like has an responsible for interdomain routing. So it means that it will determine how packets should be routed between different autonomous system or AS across the internet. So this is very crucial for maintaining the decentralized and also for distributing nature of the internet. And for the next is about the policy on like policy based routing. So the BGP allows like network administrator to define routing policies to control how traffic enters or exit their network. So these policies are like often based on business relationship, so rather than pure technical consideration. And also this routing protocol, not routing protocol, this routing policies is enabling like BGP for decide the router to accept or reject or prioritize based on various attributes like perfect length and then IS path and also next hop and and etc. And for the fifth, it's about the attributes. So the BGP use a set of attributes to make routing decision. For the first attribute is about the aspect, the list of AS that a route traverse like shorter aspect are typically preferred. And also for the next is about next hop, the IP address of the next router in the path for reaching the destination. And the third is about local preference, a metric used within an AS to prefer certain paths over others. And the next is about the multi-exit discriminator, or we can say MED. So this suggests the preferred route when multiple path access between the same two assets. And the next is about origin, indicates how the route was learned, like via IGP or EGP or incomplete. And for the last attribute is about community that like text that help classify routes for specific policy based on decision. For the next is about the BGP peering. So the BGP routers, also called peers, that established like TCP session with one another over port 179. So two types of peering relationship access. For the first type is internal BGP, or we can say IBGP. So this BGP session between routers within the same AS. And for the external for the external BGP, we can say eBGP. So the BGP session in here is between router with different AS number. For the next is about the convergence. So the convergence is slow to converge compared to other routing protocols. So when a change like occurs in the network, so the BGP router must update their route table and propagate these updates for peering, and yeah, that can take a lot of time. So the slow convergence is one of the trade-off for BGP's flexibility and scalability. And for the next is about the security concerns. So the BGP is susceptible to several security issues, such as route hijacking and man-in-the-middle attacks. So because BGP doesn't inherently validate like the authenticity of routes, so the malicious entities can inject incorrect routers, and also which can lead to traffic misdirection. So this has led to the development of solution like resource public key infrastructure, or we can say RPKI, RPKI. So to validate the origin of BGP routes. And then the next is about the scalability of BGP. So the internet is fast, like, and the number of routes that BGP must handle continues to grow. So the modern BGP implementation must efficiently manage this fast routing table, which includes hundreds of thousands of routes. And then, yeah. Oh, and the last is for the application or implementing of BGP. For the first is about internet service provider. So the BGP is very critical for ISPs to manage traffic exchange across the internet. And for the next is about enterprise networks. For the large organization that connect to multiple ISPs, often use BGP for redundancy and load balancing. And for the last is about the content delivery networks, or we can say CDNs. So CDNs use BGP to ensure optimal like delivery of content by routing traffic to the nearest server based on network condition. So for the conclusion is the BGP is the backbone protocol of the internet, enabling autonomous system to exchange routing information, and also ensuring that data can travel across the complex web of interconnected networks. While the BGP is incredibly powerful and flexible, it requires careful management to ensure security, stability, and efficiency in routing traffic across the global internet. So that's all for the explanation about the BGP. So now we're going next to the uh, fundamental configuration about the IBGP peering. So let's get to the lab. For the first, we're going to add two routers in here. Save. Then you have to connect each other and then turn on. Okay, now I'm going to add the information first. Interface will be back. So the interface feedback 1.1 is for the router 1, and for the next is network 2.2. It's for the second router. And then we're adding the IP address for each interface that are connect each other. edit. I'm going to use network 12 with prefix 24 to make it easy. Then yeah, as usual, we have to like uh, advertising all of the network. Okay, enable and then configuration terminal. We rename it first the router. So this for the router one, and then going to the interface Ethernet 0/0 with the IP address. Don't forget 12.1 with the prefix 24. Then after that, don't forget to launch shutdown. Then make the IP loopback or interface loopback 0 and then IP address network 1.1 the prefix 32. Then do right. Okay, so this is for the basic configuration at the interface. And then next to the second router, enable configuration terminal host name router 2, and then interface 0/0, IP address 12.2, and the prefix 24. Then no shutdown, then interface will take 0, and then IP address again, and then the prefix 32 also, and then don't forget to do right to make it safe. Okay, so after we already make an or configured for the basic configuration, now we have to add the router BGP and the IS number is 12. Then don't forget to add the neighbor 12.2, and then don't forget for the remote AS. So this is to remoting, and that number 12 is like the AS number that will be the path to connect or to neighboring to the network. And don't forget to do right again. And we move to the second route. So for the command is same through BGP12, but the difference is just at the network. The neighbor 12.1 and then remote is 12. And do right. Okay. So as you can see in here, there is an what's the name notification that so the meaning of this notification is the adjacency is already up from down to the up. So it means that already the router one is already being a neighbor for the router 2 from the BGP. And then we're going to check to so the command is to show IPBGP the show IPBGP summary. Okay, so as you can see in here, the neighbor for from the network router 2, it's already get into the table routing from router 1, especially at the BGP. So this is for the network, and then after we um, make the network, so for the next we also have to advertise the network that we have made before. So the network for this router BGP is from the interface loopback 0 that we have made before. So network 1.1.1, and don't forget for the subnet mask, but we can just type mask 32, then do right. Okay, and also at the router 2, don't forget network 2.2.2, and then mask. Okay, then do right. And after that, we can to test ping each other from the router 1 to the router 2, do ping 2.2.2. Okay, it's successful. And also in here, a success too. So it means that the router BGP is already working. And now we're going to check the do show IP route BGP or check the table routing. Okay, so this is the network from the second router. So there's the flag. There's a flag. The flag is B. The B it's mean BGP where this. Okay, and yeah, because yeah, it's done. That's all for the what you can say fundamental configuration of IBGP peering. Okay, that's all for this occasion. So thanks for watching, and I hope you can take a good lesson from this video tutorial. And the last I say, Assalamualaikum warahmatullahi wabarakatuh.